This is an elegant problem to find out acceleration of the chain here, and the chain is placed on any arbitrary surface, and here the surface is of course frictionless, so mu is equal to 0, and the chain is uniform, so its mass per unit length lambda is constant, and the vertical separation between the endpoints is h, and the length of the chain is given to be L. We need to find acceleration of the chain when it is released from rest. So initial velocity of the chain is 0, and initially we need to find acceleration when it is released from rest. So this type of problems can be solved using projection methods. So other variations of the problems are also there, like a chain is kept on the sphere, like some part of the chain is there, and this chain is uniform, making an angle theta, and we need to find acceleration of the chain when it is released, and problems like that. This problem is also given in Krotov. So let's solve it out using projection method. And by the way, projection method is really an important concept in solving physics problems, and it is used throughout, not only in mechanics but electromagnetism as well, to solve problems. So projection method, let's see what actually is this projection method. Since the shape of the surface is arbitrary, we cannot apply integration method to find out acceleration. So what we are gonna do is consider a very small dl element of the chain here, dl element of the chain, and let's see what are the forces acting on this dl element of the chain. One is the normal reaction force dn on this chain, part, dl part. Another is dm times g, and one force is tension T exerted by the right part of this dl, and another will be, let's say, the incremental tension is dt. So T plus dt will be the tension force exerted by left of dl element. So these are the forces exerted on this dl element. So basically, if we consider this dl element, so of course it will have the tangential acceleration et, this dl element, and the normal acceleration an is going to be 0, because the initial velocity is 0 and we are being asked to find out acceleration at initial moment of time. So this an is 0, since an is equal to v square over r, so this is 0. So of course we need to find at, tangential acceleration. So in the direction of tangent, the forces are tt plus dt dmg, component of dmg, right? So let's say this angle is theta, a kind of incline here for this dl element, and we can see that this theta will vary for all dl elements. So let, for this arbitrary element dl, the net components of forces along the tangential direction is dmg sine theta, component of dmg along the tangent, and also plus t minus t plus dt. These are the forces, right, along the tangent direction in this direction. So this is equal to dm mass times acceleration of this small element. So for dm we can write dm as lambda dl times g sine theta, and this becomes minus dt is equal to again lambda dl times a. A means tangential acceleration. So here lambda g is constant, and dl sine theta minus dt is equal to lambda a times dl. Now look at dl sine theta. What is dl sine theta, by the way? So in this triangle, if this angle is theta and this is dl, this will be dl sine theta, which I am writing dy. So dl sine theta is dy, so it becomes lambda g times dy minus dt is equal to lambda a dl. Now let's integrate it. Here we have used projection wisely because dl sine theta is projection. Otherwise, we will have to express length as a function of theta, which is very tedious process, and also we are not given the equation of this surface, this curve, sorry. So when we integrate it, lambda g integral dy, lambda g is constant because lambda, mass per unit length is constant. And then integral dt, here tension is zero and here also tension is zero. At both the endpoints, tension will be zero because there is no other element. For this part, there is no other element towards right, and for this part, there is no other element towards left. So from 0 to 0 and dy, integral dy is going to be h, right? Because all the dy adds up to h. So it becomes 0 to h, lambda a constant. Integral dl, all the dl element adds up to the length of the chain, that is 0 to l. So we get lambda g times h is equal to lambda a times L. And also please note that lambda is constant and acceleration of the chain at initial moment is also constant because tangential acceleration, which is rate of change of speed for all the elements, is going to remain same. That's why I have taken a out of integration at initial moment. After some time, when velocity of the chain will be there, then acceleration of all the parts of the chain is not going to remain same. So here we have this a as lambda gets cancelled and we have g h over l. That is our acceleration of the chain at initial moment of time. If you have any confusion, do comment below, and if you like this video, please subscribe and like and share this video. Thank you very much.